So let's discuss the remaining questions of Lagrange's multiplier method. So this question says that which point on this sphere is at maximum distance from given point. So what we'll do is we'll assume that let x, y, z be any point on the sphere which is at maximum distance from given point P. So by distance formula we can calculate distance in between the point P and the point on sphere. So let's name that point as Q. So by distance formula, distance in between P and Q will be basically under root x minus 2 square plus y minus 1 square plus z minus 3 square. So we are supposed to basically maximize this distance provided the condition that is the equation of sphere. So maximizing this distance is same thing as maximizing the square of the distance, that is x minus 2 square plus y minus 1 square plus z minus 3 square. So let's define our function capital F. That will be x minus 2 square plus y minus 1 square plus z minus 3 square plus lambda times x minus 2 square plus y minus 1 square plus z minus 3 square. So d of f will be, if I take its total derivative, that will be 2 times x minus 2 plus, here the condition will be x square plus y square plus z square minus 1. So its total derivative will be 2 lambda x dx plus 2 times y minus 1 plus 2 lambda y dy plus 2 times z minus 3 plus 2 lambda z into dz. So if I just compare the total derivative with 0 to get the possible points where the distance can be maximum, so that basically gives me 2 times of x minus 2 plus lambda x equals to 0 and 2 times y minus 1 plus lambda y equals to 0 and 2 times z minus 3 plus lambda z equals to 0. Let's name these equations as 1, 2 and 3. Now if I just solve it for, I can just solve these equations 1, 2 and 3 for values of x, y and z. So from here my x will be basically minus lambda by basically 2 by 1 plus lambda. 2 by 1 plus lambda. Likewise from equation 2 my y will be 1 by 1 plus lambda, and from equation 3 my z will be 3 by 1 plus lambda. Now we already have a condition in x, y and z, that is x square plus y square plus z square equals to 1. So if I just substitute these parametric values of x, y, z, that will help me solve it for lambda. So it gives me 2 square plus 1 square plus 3 square equals to 1 plus lambda square. So from here I'll get 9 plus 1 10 plus 4 14 equals to 1 plus lambda square. So from here 1 plus lambda equals to plus minus under root 14. So lambda is basically minus 1 plus minus under root 14. So I got my lambda, and using this lambda I can easily find out values of x, y and z. So that will be my x, y, z, that is the possible points where the distance pq can be maximum or basically can attain extreme values, are plus minus 2 by root 14 plus minus 1 by root 14 and plus minus 3 by under root 14. So there are 2 points. Let's name them as A as 2 by root 14, 1 by root 14 and 3 by root 14, and point B as minus 2 by root 14, minus 1 by root 14 and minus 3 by under root 14. So I got these 2 points where the distance PQ can attain extreme values. Now I need to check like at which point will it attain maximum distance and where it will attain minimum distance. So from here, if I calculate second order total derivative of f, so that will be basically two plus 2 lambda into dx square plus 2 plus 2 lambda into dy square plus 2 plus 2 lambda into dz whole square plus 2x minus 2 plus 2 lambda x into d square x plus 2 into y minus 1 plus 2 lambda y into d square y plus 2 into z minus 3 plus 2 lambda z into d square z. So this is the value of second order total derivative of f, and if you observe that at these points a and b, we'll get this and this term as 0, because by taking that only we reached to point a and b. So my d square f is reduced to 2 plus 2 lambda into dx square plus dy square plus dz square, and this thing will be equals to, now we are supposed to check it at point A and B both. So d square f at point A. Now at point A, I assumed my lambda to be, basically my 1 plus lambda to be under root 14. So here my lambda is basically under root 14. Minus 1 plus under root 14. So that this will basically give me 2 into 1 plus lambda will be under root 14 times dx square plus dy square plus dz square greater than 0. This value will always be greater than 0 because this thing is always positive, and 2 into under root 14 is also greater than 0. So from here I can say that at point A, the distance PQ is basically minimum. Now let's check it at point B. So at point B, 1 plus lambda is basically minus under root 14. So d square f will be 2 into minus under root 14 into dx square plus dy square plus dz square, and this thing is always greater than or equals to 0, but minus of 2 under root 14 is less than 0. So this whole thing will be less than or equals to 0 at this point B. So from here I can say that at point B, distance PQ is basically is maximum. So point B, that is minus 2 by under root 14 and minus 1 by under root 14 comma minus 3 by under root 14 is at maximum distance from the given point P, that is 2, 1, 3. Now let's move on to the next question. So the next question says that find the absolute maximum and minimum values of this function over this region. So they have given us a function in two variables x and y, and we are supposed to find its extreme values in this region. So let's define our function capital F, that would be x square plus 3y square minus y plus lambda times x square plus 2y square minus 1. So if I take its total derivative, that will be 2x plus 2 lambda x into dx plus 6y minus 1 plus 4 lambda y into dy. So if I equate total derivative with 0 to get the possible critical points, that basically gives me x plus lambda x into 2 equals to 0, or 6y minus 1 plus 4 lambda y equals to 0. Now if I solve it for x and y, this basically gives me x equals to 0 or my lambda is equals to minus 1. And from here I'll get my y equals to 1 divided by 6 plus 4 lambda. So I got these two values, that is x equals to this and y this. So we have a relation in between x and y, that is x square plus 2y square is less than or equals to 1. So its boundary will be x square plus 2y square equals to 1. So if my x is equals to 0, then my y is basically 2y square equals to 1. So from here y square is 1 by 2. That basically gives me y as plus minus 1 by root 2. So one of the possible critical points is 0, plus minus 1 by root 2. Likewise, from the first equation, I got my lambda equals to minus 1. So if my lambda is minus 1, then my y will be basically 1 by 6 minus 4, that is 1 by 2. And if my y is 1 by 2, let's see what we get as x square plus, so x will be basically x square plus 2 into y square, that is 1 by 4 equals to 1. So x square is equals to 1 minus, this will be 1 by 2, that is 1 by 2 only. So x will be plus minus 1 by root 2. So other points are plus minus 1 by root 2, 1 by 2. So these are the 4 critical points. Now we're supposed to check its values at, like basically check where it attains maximum, absolute maximum, and where it attains absolute minimum. So one way to check is just find out the value of function at these points. So first let's do that. So my function f(x, y) is basically x square plus 3y square minus y, x square plus 3y square minus y. So let's check its values at all the points. So f at 0, 1 by root 2 will be 3 by 2 minus 1 by root 2, that is 3 minus root 2 by 2. Likewise f at 0, minus 1 by root 2 will be 3 by 2 plus root 2 by 2, that is this. Likewise at 1 by root 2, 1 by 2, it will be 1 by 2 plus (1 by 2) plus 3 by 4 minus 1 by 2. This basically gives us 3 by 4. And f at minus 1 by root 2, 1 by 2, it will be 1 by 2 plus 3 by 4 minus 1 by 2. That basically gives us 3 by 4 only. Now we're supposed to check like which one is maximum and which one is minimum. So like this value 3 by 4 is basically 0.75, and 3 minus under root 2 divided by 2 is 0.79 something, and this 3 plus root 2 divided by 2 is 2.20 something. So you can see that this one, like at 0, minus 1 by root 2, f attains maximum value, and at 0, basically at these 2 points, that is at plus minus 1 by root 2, 1 by root 2, f attains minimum value. Now this is one way to check. Other can be, you can just find out its second order total derivative of f and then check at specific point, like based on the sign. If it is greater than 0, then there it attains minimum, and if it is less than 0, then there it attains maximum. So based on it you can say like whether it attains minimum or maximum. And like even after checking these things, you are supposed to check like where it will be absolute minimum and absolute maximum, because it will tell you about local extreme points. So that for that you need to check its value at specific points, that is this thing. So that's all for this question. Let's move on to the next question. So the next question says that a rectangular box opens at top and is said to have a volume of 32 cubic units. So volume is 32 cubic units, cubic meter, that is, and we're supposed to find the dimension of box so that the total surface area is minimum. So minimize total surface area. Now if you see the rectangular box, it will be somewhat like this. And it is open from the top. So if it is open from the top, the surface area of box will be surface area of box. So let's say this is x, that is the length, this is y, that is the width, and this is height, that is z. So total surface area will be xy plus 2 times yz plus 2 times xz, that is xy plus 2 yz plus xz. So we are supposed to basically minimize this area provided the volume is this, that is volume will be xyz only. So if we define our function capital F, that will be xy plus 2xz plus 2yz plus lambda times xyz minus 32. So this is the total surface area that we got. Like this is basically the relation F, and here lambda is basically the Lagranges multiplier. So its total derivative will be y plus 2z plus lambda yz equals to into dx plus x plus 2z plus lambda xz into dy plus 2x plus 2y plus lambda xy into dz. Now if I just equate df with 0, so I'll get basically y plus 2z plus lambda yz equals to 0. Let's name it as equation 1. Likewise, I'll get x plus 2z plus lambda xz equals to 0, that is 2, and 2x plus 2y plus lambda xy equals to 0. Let's name it as 3. Now if I just multiply equation 1 with x, equation 2 with y, and equation 3 with z, and just add in these three equations, so I'll get xy x into y plus 2z plus lambda yz plus y into x plus 2z plus lambda xz plus z into 2x plus 2y plus lambda xy equals to 0. So if I simplify it, I'll get xy plus 2xz plus yx plus 2yz plus 2xz plus 2yz plus 3 times lambda xyz. And we know that lambda xyz is basically given to us as 3. Now if you see that, it is basically 2 times xy plus 2 times xz plus 2 times yz plus 3 into lambda into 32 equals to 0. Now this is the value we're supposed to minimize, so let us assume it as u, that is u equals to xy plus 2xz plus 2yz equal, let's assume it as u. So if it is u, so our relation reduced to 2 times of u plus 96 lambda equals to 0. So from here you got u as minus 48 lambda. Now I guess it doesn't lead us anywhere, so let's do one thing. Let's just subtract these two equations. Let's just subtract 1 from equation 2, so that basically gives me x minus y plus lambda z into x minus y equals to 0. So from here if I take x minus y common, I'll get 1 plus lambda z equals to 0. That basically gives me x is equals to y or z is equals to minus 1 by lambda. Now these are the two relations that I got. Likewise, if I just subtract 2 times of 2 from 3, that is minus 2 times 2, that will basically give me y minus 2z into 2 plus lambda x into y minus 2z equals to 0. So if I take y minus 2z common, so I'll be left with 2 plus lambda x equals to 0. So from here I got y equals to 2z and lambda equals to minus 2 by, basically x equals to minus 2 by lambda. So I got my relation as x is equals to y is equals to 2 times of z, and we know that x into y into z is basically 32. So from here I'll get 4z cube equals to 32. That basically gives me z cube equals to 8. So from here I got my z as 2. So if my z is 2, then my x is equals to y is equals to 4. So my units are basically 4 comma 4 comma 2. So 4 length, 4 width and 2 height, like any parallel loop pipe of this. Now we're supposed to check whether the value is basically, surface area is basically minimum at this point. So for that we need to find d square of f, and it will be minimum at this point if at this point, that is 4 comma 4 comma 2, it turns out to be greater than 0. So if I calculate its d square f, so that will be basically 1 plus lambda z into dx dy and 2 plus lambda y into plus 2 plus lambda y into dx dz plus 1 plus lambda z into dx dy, 1 plus lambda z into dx dy plus 2 plus lambda x into dz dy plus 2 plus lambda y into dx dz plus 2 plus lambda, from here 2 plus lambda x into dy dz and plus y plus 2z plus lambda yz into d square x plus x plus 2z plus lambda xz into d square y plus 2x plus 2y plus lambda xy into d square z. So if you'll check its value at 4 comma 4 4 2 and lambda will be basically minus 1 by z. From here lambda will be minus 1 by z, that is minus 1 by 2. So from here this term will be basically 0 because lambda z will be minus 1. Likewise lambda of y will be minus 2, this is also 0. Likewise this again goes to 0, this also 0, this and this also 0. Now we'll supposed to check these three values. So this will be 4 plus 2 2s are 4 minus 1 by 2 into 4 into 2 into d square x plus 4 plus 4 minus 1 by 2 into 4 into 2 into d square y plus 8 plus 8 minus 1 by 2 into 4 into 4, that is d square z. So it basically gives us 4 d square x plus 4 d square y and 8 d square z, and if you see that it will be always greater than or equals to 0. So that basically proves us for these length, that is length 4, breadth 4 and height 2, the surface area will be minimum. And that's all we are supposed to prove in this question. So let's move on to the next question. So the next question says that find the height of the cylinder of maximum volume that can be inscribed in a sphere of radius a. Let us assume that this be a sphere of radius a. So its equation will be x square plus y square plus z square equals to a square. And a cylinder is basically inscribed inside this sphere. So that will be like this. So let's draw a axis of cylinder and it will be passing via center of the sphere, that is 0 comma 0 comma 0. Now let's assume that h be the height of cylinder and we are supposed to maximize the height only. So this center of sphere will be at half of the height, so this will be h by 2. And if I just draw in this center O to this point where the cylinder is touching the sphere, let's name it point as A. And then if r is the radius, then I can write r square plus h square by 4 equals to radius of sphere, that is a square. So from here I got my radius of a cylinder as a square minus h square by 4 under root. Now we are supposed to find the height of cylinder such that the volume is maximum. So volume of cylinder will be pi r square h, and we have already calculated value of r in terms of h, so that basically gives us pi h into r square, that is a square minus h square by 4. So it is pi into a square h minus h cube by 4. So this is the volume we are supposed to maximize given this condition of sphere. So our function f will be basically pi a square h minus h cube by 4 plus this is the volume we are supposed to maximize provided this sphere. So it turns out to be in one dimension only. So d of f will be basically df by dh will be basically pi into a square minus 3h square by 4. So it will give us critical points when a square is equals to 3 by 4 h square. So from here h square will be 4a square by 3. That basically gives us h as 2a by root 3 because height will always be positive, so I am taking only positive thing. And d square f by dh square will be pi into minus 3 to the 6 h by 4, that is minus 3 pi by 2 into h, that is 2a by root 3, and this thing will be always less than 0. So for height h equals to 2a by root 3, volume of cylinder is maximum. And that's all we're supposed to show in this question. We're supposed to basically find the height, and height turned out to be 2a divided by root 3. So let's move on to the next question. So the next question says that find the maximum or minimum value of this. That is, we are supposed to find extreme value of x square plus y square plus z square subject to this condition and this, and interpret the result geometrically. We have seen this question, like it is a repeated question, and it's like the third time it got repeated. So here our function f will be basically x square plus y square plus z square plus lambda 1 times ax square plus by square plus cz square minus 1 plus lambda 2 into lx plus my plus nz. So this is the function f, and we have seen that the geometrical interpretation will be basically the perpendicular distance from origin to the tangent plane to the ellipsoid. Basically that's the geometrical interpretation. And like they have asked a specific case of it as well, where they took specific values of L, M, N and A, B and C. So it's like repeated 3 times. So let's move on to the next question. So the next question says that find the minimum value of this subject to the condition this by method of Lagranges multiplier. So here function f is x square plus y square plus z square plus lambda times x y z minus a cube. That basically gives me d of f as 2x plus lambda yz into dx plus 2y plus lambda xz into dy plus 2z plus lambda xy into dz. Now if I equate it with 0, I'll basically get 2x plus lambda yz equals to 0. Let's name it as 1. And 2y plus lambda xz equals to 0. Let's name it as 2. And 2z plus lambda xy equals to 0. Let's name this equation as 3. Now if I just multiply these, like the equation, if I just multiply equation 1 with x, 2 with y and equation 3 with z, and just add in these 3, so I'll basically get 2 times of x square plus y square plus z square plus 3 lambda xyz equals to 0. But in the question my xyz is basically a cube, so this basically gives me 2 times u plus 3 lambda a cube equals to 0, where I assumed u equals to x square plus y square plus z square. So from here my u is minus 3 lambda by 2 a cube. Let's name it as relation 4. Now if I just substitute equation 1 from equation 2, I'll get 2 times y minus x plus lambda z into x minus y equals to 0. So from here I can take y minus x as common. So I'll get 2 minus lambda z equals to 0. Likewise, if I just subtract equation 3 from equation 2 from equation 3, so I'll get 2 times z minus y plus lambda x into y minus z equals to 0. So if I take z minus y as common, so it will be 2 minus lambda x equals to 0. So from here I'll get y equals to x, and from here I will get basically y equals to z. So my relations are x is equals to y is equals to z, and we know that xyz is a cube. That basically gives my x equals to y equals to z is equals to a. So this is the value of xyz, and using this I can calculate value of lambda from here. So lambda will be basically minus 2u by 3a cube. So it will be minus 2 by 3a cube into u will be 3a square. So we got our lambda as minus 2 by a. Now let's check like whether at this point, that is a and a, the value of function is minimum. Now it further shows that if this is the case, then show that its value is this, and this is the repeated question. Right now we discuss this question, repeated question. Now let's move on to the next question. So it says that using Lagrange's multiplier method, find the shortest distance between this line and this ellipse. Again, it is a repeated question. We have seen this question earlier. Like here, you'll assume that alpha comma beta is any point on the ellipse, and if it's at minimum distance from ellipse, then you'll use the distance formula from a point on a line, and then you'll try to basically minimize that. We have seen this exact same question earlier. So let's move on to the next question. So this question says that find the minimum distance of the line given by plane this and this from the origin by method of Lagrange's multiplier method. So let's assume that x, y, z be any point on the given line. So the equation of line is 3x plus 4y plus 5z minus 7 equals to 0, and x minus z minus 9 equals to 0. So this is equation of given line. So let us assume that x comma y comma z be any point on the line L, on line L. So the distance of this point from the origin will be distance, let's name this point as P. Distance of P from origin O, that is 0, 0, 0, will be x square plus y square plus z square under root, and we are supposed to minimize this distance. So minimizing this distance is same as minimizing the square of distance, that is x square plus y square plus z square. So let's see what will be our function f. That will be x square plus y square plus z square plus lambda 1 into 3x plus 4y plus 5z minus 7 plus lambda 2 into x minus z minus 9. Now if I just take its total derivative, that will be 2x plus 3 lambda 1 plus lambda 2 into dx plus 2y plus 4 lambda 1 into dy plus 2z plus 5 lambda 1 minus lambda 2 into dz. Now if I just equate it with 0, so I'll get 2x plus 3 lambda 1 plus lambda 2 equals to 0, and 2y plus 4 lambda 1 equals to 0, and 2z plus 5 lambda 1 minus lambda 2 equals to 0. Let's name these equations as 1, 2 and 3. So if that's the case, so I can just solve these four values of lambda 1 and lambda 2. So from here I'll get my so if I just solve these for x, y and z, so my x will be minus 3 lambda 1 plus lambda 2 by 2. My y will be minus 4 lambda 1 by 2, that is minus 2 lambda 1, and my z will be minus 5 lambda 1 minus lambda 2 by 2. So these are the values of x, y and z. So these must satisfy the equation of line. So the equation of lines are 3x plus 4y plus 5z is equals to 7, and another is x minus z equals to 9. So if I solve x minus z equals to 9, that basically gives me minus 3 lambda 1 minus lambda 2 plus 5 lambda 1 minus lambda 2 is equals to 18. So from here I'll get 2 lambda 1 minus 2 lambda 2 equals to 18. That basically gives me lambda 1 minus lambda 2 equals to 9. So this is the first relation in between lambda 1 and lambda 2. Now just substituting value of x, y and z in this equation will give me another relation in between lambda 1 and lambda 2. So if I do so, I'll get minus 9 lambda 1 plus 3 lambda 2 by 2 plus 4 y, that is minus 4 lambda 1 by 2 plus 5 z, that is minus 5 lambda 1 plus lambda 2 by 2 equals to 7. So this basically gives me minus 9 lambda 1 minus 3 lambda 2 minus 16 lambda 1 minus 25 lambda 1 plus 5 lambda 2 equals to 14. So from here, if I simplify it, it will be 16 plus 9, 25 plus 25 minus 50 lambda 1 and plus 2 lambda 2 equals to 14. That basically gives me minus 25 lambda 1 plus lambda 2 equals to 7. So this is the second relation in between lambda 1 and lambda 2. Now if I just solve in these two relations, I'll get my it is lambda 1 minus lambda 2 equals to 9 and minus 25 lambda 1 plus lambda 2 equals to 7. So from there I'll get minus 24 lambda 1 equals to 16. That basically gives me lambda 1 as minus 2 by 3. And if this is lambda 1, then lambda 2 will be lambda 1 minus 9. That is minus 2 by 3 minus 9. This is minus 2 minus 27 by 3, that is minus 29 by 3. So these are the values of lambda 1 and lambda 2. And using these values of lambda 1 and lambda 2, I can easily find out value of x, y and z. That will be basically the point on the line, basically the point on the given line, which will be at minimum distance. Which will be at minimum distance from the line. And you can also verify this by calculating a d square f. That will be 2 times dx square plus dy square plus dz square plus this thing 2x plus 3 lambda 1 plus lambda 2 into d square x plus 2y plus 4 lambda 1 into d square y plus 2z plus 5 lambda 1 minus lambda 2 into d square z, and these terms will go to 0 and this thing will be greater than 0 at this point. So that basically gives us that the distance will be minimum. So you can just plug in values of lambda 1 and lambda 2 here in these values of x, y and z, and that will give you a specific point. So the next question says that find the point on this sphere that are closest and farthest to this point. So let us assume that x, y and z be point on the sphere that is at a minimum or maximum distance from this point. So by distance formula, distance will be x minus 3 square plus y minus 1 square plus z plus 1 square plus lambda times x square plus y square plus z square minus 4. So this will be our function f, and you can just calculate df. So that will basically give you 2 points, and then you can check d square f at those 2 points, and that will tell you which is at maximum distance and which one is at minimum distance from this point. So this one is again a repeated pattern, like these type of questions are asked a lot. So let's move on to the next question. So in this question, like in the next question, we are supposed to find the shortest distance from origin to the given hyperbola. So let us assume that point x comma y on the given hyperbola be at shortest distance from origin. Then by distance formula, the distance between origin and this point on hyperbola will be x square plus y square under root, and our function f will be, because we are supposed to minimize this, so minimizing this is same thing as minimizing x square plus y square. So capital F will become x square plus y square plus lambda times the given condition of hyperbola, that is x square plus 8xy plus 7y square minus 2 to 5. So from here I can calculate df, that will be 2x plus 2 lambda x plus 8y into dx plus 2y plus 8x plus 14y into dy, and then you can just equate df with 0. That will give you 2x plus 2 lambda x plus 8y equals to 0, and 2y plus, here it will be lambda as well, and here also there will be lambda, and here as well. So it will be 8 lambda x plus 14 lambda y equals to 0. Now you can just solve in these two equations for either lambda or x and y, and that will give you relation, and you can just solve in that to find the shortest distance. So if you will solve it, so you'll get you can reduce these to x into 1 plus lambda plus 4y lambda equals to 0, and y into 1 plus 7 lambda plus 4 lambda x equals to 0. Now if you'll find x by y, here from here it will be minus 4 lambda by 1 plus lambda, and from here y by x will be minus 4 lambda by 1 plus 7 lambda. Now you can just multiply these two equations, that will give you 1 equals to minus 4 lambda by 1 plus lambda into minus 4 lambda by 1 plus 7 lambda. Now you can just solve it for lambda, that will be 1 plus lambda into 1 plus 7 lambda equals to 16 lambda square, and on the left hand side you will be left with 1 plus 8 lambda plus 7 lambda square equals to 16 lambda square. So that basically gives you 1 plus 8 lambda equals to 9 lambda square. So from here it will be 9 lambda square minus 8 lambda minus 1 equals to 0, and you can write it as 9 lambda square minus 9 lambda plus lambda minus 1. So that simplifies to, if you take 9 lambda common from these two terms, that will be lambda minus 1 plus lambda minus 1 equals to 0. Now you can take lambda minus 1 as common, you will be left with 9 lambda plus 1. That basically gives you lambda is equals to either 1 or lambda is equals to minus 1 by 9. So for two values of lambda, you will get basically two relations in between x and y. So if lambda is equals to 1, then x by y will be minus 4 by 2, that is minus 2. So that basically gives us x equals to minus 2y. Likewise, if lambda is minus 1 by 9, then 1 plus lambda will be 8 by 9. So x by y will be 4 by 9 divided by 8 by 9. That basically gives us 1 by 2. So from here 2x is equals to y. So these are the two relations, and if you'll substitute these relations in the given condition, that is x square plus 8xy plus 7y square is equals to 2 to 5. So from here you will get specific values of x and y. So that will, and then you can check by substituting it in d square f, and based on the sign you can conclude that which one will be at shortest distance from the origin. So let's move on to discuss the next question. So it says that show that a box of maximum volume V with prescribed surface area is a cube. So the surface area of a box is basically given and its volume is maximum. So volume will be x, y, z, and with prescribed surface area. So surface area will be 2 times xy plus yz plus zx. Let's say that it is equals to a. So we are supposed to basically maximize this function. So our f will be xyz plus lambda times 2xy plus 2yz plus 2zx minus a. Now we can just solve it for x, y and z. We can calculate df, so that will basically give us a point. We have done a similar question. In that, basically we're supposed to maximize surface area and volume is given, but now we're supposed to maximize the volume and surface area is given to us. So that's a similar type of question. You can proceed it in that way. So let's move on to the next question. So the next question says that a rectangular box open at top is to have surface area of 12 units. Find the dimension of box so that the volume is maximum. Again, it is a repeated type. We have seen if the box is open at top, then its surface area will be xy plus 2 xz plus 2 yz, and it is given to us as 12 units. So the condition will be this, and we are supposed to basically maximize the volume, that is xyz plus lambda times this condition. This is the similar question as this. Like here we have assumed that surface area to be a, and in this question they have given us that surface area is 12. So if we put a equals to 12, then it is the similar question as previous one. Now let's see the next question that says that find the extreme value of xyz if x plus y plus z is equals to a. So f will be xyz plus lambda times x plus y plus z minus a. So if you'll find df, it will be yz plus lambda into dx plus xz plus lambda into dy plus xy plus lambda into dz. So from here you can equate df with 0. That will basically gives you yz plus lambda equals to 0, xz plus lambda equals to 0, and xy plus lambda equals to 0. So if you'll solve it, you'll get, you can just multiply this first equation with x, second with y, and third with z. You'll get 3xyz plus lambda times x plus y plus z equals to 0. So from here you'll get 3xyz plus lambda times a equals to 0. So if we assume it as u, so we'll get 3u plus lambda a equals to 0. So that basically gives you relation in between u and lambda. So other relations you can find out by subtracting 1 from 2. That will give you z into x minus y equals to 0. So from here either z is 0 or x is equals to y. Likewise, if you subtract equation 2 from equation 3, you will get x equals to 0 or y equals to z. But we are supposed to find the extreme values. So there are 2 points, that is 0, 0, 0, and x is equals to y is equals to z. So if we take x equals to y equals to z, then this relation basically gives us 3x equals to a, that is x equals to a by 3. So another point will be a by 3, a by 3, a by 3. And using this relation in between lambda and u, we can get our lambda as minus 3u by a, and u is x, y and z, that is minus 3 by a into a cube by 3 cube. That basically gives us minus a square by 9. This is our lambda. Now you can just find out d square f and try to check its sign whether it's greater than 0 or less than 0. So if we calculate d square f, that will be z into dx dy plus y into dx dz plus z into dx dy. So it will be 2 times this and 2 times x into dz dy. Now if you'll check it at basically 0 comma 0 comma 0, so that will give you 0 only, so we cannot comment anything about this point 0 comma 0 comma 0. But if we'll check it at a by 3, a by 3 and a by 3, so it will be 2a by 3 into dx dy plus dx dz plus dy dz. And based on the value of a, like whether it's greater than 0 or less than 0, you can comment whether at this point it will be maximum or minimum. Was the last question for this topic, that is the Lagrange's multiplier method. And if you see that, like so many questions were asked on this topic, like at least one question is asked each year, and the format of the questions are also repeated. Like there are only specific type of questions that are asked. So like even if you do the previous year questions properly, then also you'll be able to have a perfect, you'll be able to get the hold of this topic. So thank you for watching, and please like, share and subscribe the channel. Thank you.